Welcome to the Mind Spark, bringing you the latest news from around the world. This is gonna blow your mind. Ghost in the machine, screams one headline. Webb spots mystery object near dead star, declares another. The news ripples through the scientific community, then out into the world. For decades, dying stars were seen as the universe's final silent moments, a cosmic graveyard. We thought these were places where the story of the cosmos ended, the lights went out, and all that remained was silence. But science thrives on the unexpected. On June 26, 2025, that quiet picture was shattered. The James Webb Space Telescope, our golden eye in the sky, was pointed at a white dwarf star, WD 0137349. Astronomers expected to see the faint glow of cooling debris, the remains of shattered planets. Instead, they found something else. Something that pulsed with a strange rhythmic energy, a flicker of heat in the cold darkness, a heartbeat where there should have been none. Suddenly, the graveyard wasn't so empty. This discovery challenges our most basic assumptions about the final stages of a star's life. What if these stellar remnants aren't just endpoints? What if they're hiding places, preserving secrets from a long-lost era? The implications are staggering. We've been searching for life around sun-like stars, but what if a civilization could outlive its star? The silent, cold darkness of space just got a little bit warmer and a lot more interesting. So, what did Webb actually see? Not a flashing light, but a pulse of heat, an infrared flicker from an object orbiting the white dwarf. This wasn't a random fluctuation. It was a structured, repeating pattern. Every 27 minutes, like clockwork, it emitted a burst of thermal energy. The object is small, maybe a few kilometers across, but its behavior is what's remarkable. Unlike planets or asteroids, which change temperature gradually, this object heats up and cools down rapidly, as if something inside is turning on and off. It's not the signature of a simple rock, it's the signature of a complex system. Imagine scanning a dark forest with a thermal camera and seeing a single point of light flash on and off. You'd suspect intelligence. That's the feeling astronomers got. The flicker is so precise, so out of place, it forces us to consider possibilities once confined to science fiction. For hours, Webb watched. The pulse didn't waver or fade. It just kept repeating. In nature, perfect repetition is rare. A repeating signal suggests a cause, a mechanism. It suggests information. We don't know what that information is or who or what it's for. But the flicker itself is a message. I am not random. I am not natural. I am here. And for the first time, we're listening. The universe just got a little less lonely. To understand why this is so shocking, let's talk about how stars die. Most stars, including our sun, end their lives by swelling into red giants, destroying nearby planets, then shedding their outer layers. What's left is a white dwarf, a dense, hot core about the size of Earth, slowly cooling for trillions of years. Around these white dwarfs, chaos reigns. Debris disks of shattered planets and asteroids grind together, creating dust. For a long time, we thought these were lifeless ruins. Nothing complex, certainly nothing technological, could survive the violence of a star's death. That was the context for this discovery. We expected dust and rock, maybe the shattered cores of dead planets. Instead, we found something operating, like a blinking traffic light in an abandoned city. This single, pulsing object forces us to rewrite the story of what happens when a star dies. How did we find this needle in a cosmic haystack? The answer: the James Webb Space Telescope and its infrared vision. Infrared light is heat radiation. Everything above absolute zero emits it. Webb is designed to see this invisible universe, perfect for studying cold, dark debris around white dwarfs. Its gold-coated mirror collects faint heat, and its mid-infrared instrument, MIRI, acts like a high-tech thermal camera. While mapping the debris disk, astronomers expected a smooth heat distribution. Instead, they saw a single pixel brightening and dimming every 27 minutes, a pulse of heat. Without Webb, this object would have been invisible. Ground-based telescopes are blinded by Earth's own heat. Even Hubble can't see this deep into the infrared. This discovery is a testament to human ingenuity. We built a machine to see the heat of the cosmos, and it showed us something we never expected. Sometimes, the universe rewards us for looking where no one else can. The first step in science is to rule out the obvious. Could this be a planet or asteroid? No, the pulse is too rapid and regular. A brown dwarf? Too small, not massive enough, and the signal doesn't match. Magnetic fields, WD0137-349 isn't a pulsar, and the timing doesn't fit. Every natural explanation fails. We're left with a puzzle, an object that pulses like a machine, in a place where no machine should survive. When you eliminate the impossible, you're forced to consider the extraordinary. This is where things get interesting. When all natural explanations fail, scientists must consider the unthinkable artificiality. Could this be technology? The data compels us to ask. The object's behavior is more like a machine than a rock, a repeating pulse, like an engine or a beacon. Imagine a civilization facing the death of its star. Do they vanish, or do they build something to last? Maybe this is a power source, a navigational beacon, or even a message, a cosmic tombstone or library. The pulse could encode information, a language we don't yet understand. Of course, this is speculation. It's a leap from unexplained phenomenon to alien technology. But the object's stable orbit and survival through the star's death suggest it's incredibly robust. Could we build something like this? Not today, but in a million years? Who knows? The universe is old. There's been plenty of time for civilizations to rise, fall, and leave behind their ghosts. We may be staring at the relic of a long-lost intelligence. The question is, can we read what it's trying to say? The data's release sent shockwaves through astronomy. Some, like Dr. Evelyn Hayes at MIT, are thrilled. This is the kind of signal we've dreamed of. If it's not a techno-signature, it's a new kind of object. Others, like Dr. Ben Carter at Caltech, urge caution. Extraordinary claims require extraordinary evidence. We need more data. The debate is fierce but healthy. Theorists scramble for natural explanations, binary objects, strange white dwarf chemistry, anything. The burden of proof is high. NASA and ESA confirm the data's validity, but stress that analysis is ongoing. They're careful not to fuel wild speculation, but the world is watching. This isn't just another discovery. It touches on the question, are we alone? The debate reflects our hopes and fears about our place in the cosmos. For now, the scientific community is united in one thing: the need to keep looking. The search for answers has just begun. The universe has thrown us a puzzle, and we can't look away. The next chapter is being written right now. So what's next? Every major telescope is now watching WD0137-349. We need to confirm the pulse. Is it still there? Does it change? By tracking its orbit, we'll learn more about its mass and composition. Radio telescopes are listening for other signals. Maybe there's a message hidden in the static. So far, only silence. But the search has just begun. Scientists are planning to use Webb to survey hundreds of other white dwarfs. If similar objects are found, the case for an artificial origin grows stronger. We may be on the verge of discovering a galactic underworld, ancient artifacts orbiting dead stars. The cosmic graveyards may be treasure chests. The long watch has just begun, and the universe is waiting for us to listen.